Hi everyone, my name is Tianqin Li, and this is Zhengyang.
Yeah, I'm Zhengyang.
So today we're introducing our project using the Raspberry Pi to do murmur detection on device. So we're training a machine learning model that can be deployed on device that would run inference in real time that can detect the murmurs. So murmur is a kind of cardiologist conditions that would cause millions of people to die each year. And studies that shows that early detections will make this people suffer less about this disease. So we want to use the stethoscope, which is a very old technology that will listen to your heart, and add an AI component to that and make that to run on the device. So that you can run the diagnosis wherever you travel. For example, in a rural area where the connection is not very reliable, and also in a large screening setting where if you go to the cloud set, then it will be very resource expensive. So together we introduce a bunch of the model design, and which Zhengyang will talk about later, and then we actually build this product that can run actually on the device with the Raspberry Pi and like other mobile device to do the real-time murmur detection. So I will pass it to Zhengyang.
So I will introduce some basic idea of our model. So basically, for murmur detection, the input data. I mean, if you hope to detect your murmur, you will have like a streaming data stream which record your heartbeat. And in that setting, if we hope to detect murmur, we need to first run data collection and then run model inference. We observe that the model is mostly waiting for data. So we try to use like a model pipelining that could amortize the entire computation into data collection time, so we can dramatically reduce the model inference time because we don't need to wait for data. And we also introduce a mechanism using the model's prediction, internal prediction, to decide when to stop. So for each patient, we could use different patients, we could use different times to run a murmur detection. If we find a murmur very early, we could give you the result very quickly. Instead, otherwise we could run the inference longer to make your diagnosis more accurate. So using our technique, we could run our murmur detector on device, and we could have the same accuracy as the baseline model while being 2 or 3 times faster. And this is our final system and result. We deploy our system onto the Raspberry Pi, and we also ensemble a stethoscope with this Raspberry Pi, and altogether we could detect murmur directly on device without accessing to any cloud resources or network conditions. And altogether, our method could be as strong as a baseline method, but being 2 or 3 times faster. And in summary, we present a mobile heart murmur detector that is low cost and efficient, and could be deployed into rural areas for large scale screen settings. Thank you.
So we will do the live demo right now. So there's two parts of the live demo. So the one part is we want to do this on a real human, which is Zhengyang here. Yes, and then so once he click this button, it will start to record his
My heartbeat.
yes, and then the model on this device will process in real time on this edge device using this AI algorithm, and then to detect whether he has the murmur or not.
Yes. Okay, let me try it. So first, let me put a stethoscope.
Hang on, go ahead. Put
Yeah.
that up again. Oh, hold that up again, that stethoscope.
Oh, right.
No,
I'm
yeah,
sorry.
No, 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 you're good, you're good.
Yeah.
I just want you to hold it up before
Okay.
you put it
Right,
in there.
right, right.
All right, go ahead.
Yeah. So first, let me put my stethoscope on my heart. Yeah, I should find a correct location. Yeah, it's here. And I will click the button to start recording. It's collecting data and running, no murmur. It's very fast. You run several times. No murmur detected. No murmur detected. So for the second part, we were wrong because of most people, we actually don't have murmur. So for the second part, we were wrong. A recording from a real murmur patient, And we use this. This is we call it a chest phantom. It's quite simple, but we use this to simulate the heartbeat from a real person, and we play the murmur recording from a real patient, and we use our algorithm to detect heart murmur.
So you can feel the vibration even from touching it.
Yes.
So it will simulate the vibration of a heart sound.
Yes.
In this case, it's a normal heart sound. So we will start to record the heart, and then the model will run inference.
Yes,
And you can
it
see
detects
it
murmur.
correctly output the results of murmur.
Right. It's quite fast. 2 or 3 seconds, you have the first result.
Yes.
Hang on one second. Can you rerun it again for me?
Rerun it. Yes, I'm running. I'm sorry.
Yeah. This is the second time of a success murmur detection.
Yes.
And one more time.
One more time.
One more time.
Put it here. Play.
Yeah, I need you to move your arm.
Yes.
Arm.
Oh, I'm sorry. Yeah.
And rerun the program one more time.
And a third time of success murmur detection.
Yes.
Right. So thank you.
Thank you.